correlation ID for it. And you can see this guy picked it up, but this guy did not, and we'll see why that is here in just a second. But they're both subscribing to messages. This receives all of them, this is receiving every other one. So there's two subscribers to a message type there. And there can, you know, there could be hundreds. That's a little far-fetched, but it is possible. So what's happening here is this is the publisher. Here's what you have control over as a developer. And these are all, this is the configuration from within in Service Bus. It's using a Spring Builder because it uses IOC. And you can swap that out. You can use Castle. There's some other IOC containers that have been implemented, but the default is Spring Builder. I use the Castle stuff, and we'll look at that in some of the other code. We're using MSMQ, subscription storage, XML serialization or binary serialization. Here's the MSMQ transport configuration. You want it to be transactional. You don't want it to purge on startup, because if the process crashes when it starts back up, you want it to start processing the messages that have been placed in the queue. We're going to use unicast, which is peer-to-peer, most common if you're familiar with unicast, multicast, broadcast, network stuff. Then we're going to create the bus, and then we're going to start it. Here's the message that's being published, which is being happening right here. Here, it's creating an instance of an I event and then publishing that. Here it's creating an event message, which implements I event. That's why one subscriber receives both messages and the other one doesn't. One is subscribing to I events. The other subscriber is only subscribing to event message. So it's more explicit, it's more granular than the interface itself. So the one that's subscribing to I events is essentially subscribing to both these message types. It'll receive both those message types. The other one is only subscribing to event message. And you can see that here. iMessage handler is out of in-service bus. This is a handler written to handle that specific message. If we looked at this one, you can see it's handling I events. That's why it receives both. But this is typical message handler. This is what you would be writing. You just get the message and then you process it. And we're going to look at some real world talk today. Real world is, I'm telling you, is that vodka. Real world examples here in just a minute. Here's the program. Here's the main entry point for the subscriber. Again, it has its own queue. Now, if we look at the application configuration for this, here is the information that it's going to send as part of the message contract when it's making a subscription. It's going to publish a message. Here's where we're mapping endpoints. It's going to, in messages, references this assembly here, where you have the I event and then the event message. So it's going to publish a message to this message bus that says, I want to subscribe. And I turned on journaling in here. Here's a subscription message that it sent. It said, I want to subscribe to event message out of the message assembly. There's the assembly information. And the subscription type is add. Now the publisher is going to pick that up and it's going to keep that in this subscription queue. there they are. There's subscriber 1, there's subscriber 2. And where it got this worker from is, again, from that contract. This was sent as part of the message contract. So when it fired up, it said, I want to subscribe. If we go back and look at that message, there it is. It sent its endpoint as part of the message contract, which is what we saw in the slides. It sends its return address. It says, here I am, I want to subscribe, and this is where I need you to send stuff to, because that's where I'm going to listen to it for. And again, that's an administrative function. You're allowed to go in here and at any time change this. That's going to have to, in service bus, looks for XML changes and will restart the bus based on those once it sees changes. Just like any IOC container, if you go in and swap out the implementation for an interface in your config file for dependency injection, it'll notice that and it'll rewire those things up. This is the only extra piece that's in here for the server. Once it sees, once it picks up the subscription request, this is where it's going to store them. And that's where we saw those two, the worker and the worker 2. So that's typical pub sub. This is a very small, very simple little application to kind of get into and get your head around the pub sub stuff. It's all in the examples for in-service bus. And the only extra piece in here, like I said, is the storage config for the subscriptions. Now, if we get into here, how many people in here do test-driven development? Not enough. But that's okay. On the in-service bus message board, it's a Yahoo group. It's either Google group or Yahoo. I think it's Yahoo group. A lot of times there's questions that people ask about how to do particular implementations. And you answer their problems, and what you realize, and what a lot of these people realize, that if they were doing test-driven development, a lot of their questions are already answered about implementation around how to build service bus implementations for distributed messaging systems. Here is an integration test, which we cannot run because I don't think my SQL Server is set up. But here's an integration test around logging in with credentials for a user that is on the domain. Here's my authentication request message, which I'm going to give it a correlation ID, which you always have to have a correlation ID. That's how it keeps track of responses and acknowledgments, especially in full duplex scenarios. So I'm going to create a new authentication request for this particular customer with the credentials, there's the username and password for this system, member of this domain. That's where I'm setting up my context. Here's the actual test. This is a full duplex scenario. This is not a fire and forget. This is an authentication request, so I must have some sort of acknowledgement back that says, yes, you did, or no, you did not authenticate. So instead of bus.publish, we're doing a bus.send. We're going to send this message, this request, and we're going to register a callback for it, which is what this guy is, this request data complete. So when I get the request back, and I'm only going to wait about 5 seconds for that thing, when I get it back, here's the processing of it, right here. So once the async result comes back, I'm going to do several checks on it, and then I'm going to go ahead and get the authentication request message.